All right, let's take a look at number 8. It says, which of the following statements is or are true about the polynomial graph below if all of the zeros of the function are real zeros? All right, so we've got the negative root has a multiplicity of 2. Well, if they're talking about roots, then let's go ahead and identify them. So it looks like we have a root at x equals -3, and we should be able to identify the multiplicity of that as a 3. And then we also have x is equal to +3, and it looks like it just goes straight through there. It doesn't change concavity at all, so it's a multiplicity of 1. So that looks like all of the zeros, and it even says right here, all of the zeros are real. So let's take a look. The negative root has a multiplicity of 2. Well, we know that that can't be true. Multiplicity of 2 is going to be where it bounces back, or in vocabulary words, it's going to be tangent to the x-axis, and that is not true. It's actually an inflection point. Number 2 says the function is a quartic. So is it x to the 4th power? Let's take a look. If we were to add up all of our multiplicities, we can definitely see that it is going to be a 4th power polynomial. And we can even double check that by looking at the end behaviors. They're the same, so it should be an even degree. All right, so we know that 1 is not going to be a solution. So now we're looking at C or D. So we know that 2 works. Let's take a look. The positive root has a multiplicity of 1. Oh, look at that. So our +3 has a multiplicity of 1, which we've already established. So then that is also true. So C is the correct answer for that. Number 9, the graph of g of x is pictured at the right. For what values is the function greater than 0? Please notice that it does not say equal to. Okay, doesn't say equal to. It says, where is it positive? So it's going to be positive. That's an open circle, and that's an open circle. So if I were to color code this, it's going to be, well, wrong color here. It's going to be positive on this interval. So it cannot include the 0 because it doesn't say equal to. So I'm going to go from -infinity all the way to -2, but not include -2, pick back up on the other side of -2 and go to 1. And so that means I'm looking at answer choice C. All right, number 10, which of the following statements are true? Number 1, g of x is less than or equal to 0, which means it's negative or equal to 0. So it's equal to 0 here, here, negative, and here. All right, so on the interval from 1 to 3, okay, and it's bracket, so it's including that, and x equals -4. And that's true because it's equal to on that. So I would say that 1 is correct. So let's get rid of all the ones that don't contain a 1. Okay, so the rest of them contain a 1. Now let's take a look at 2. X plus 3 is a factor 1 time. So let's take a look at -3. It's not even a 0, and so that's not going to be true. So let's get rid of the ones that have a number 2 in it. And then the leading coefficient of g of x is negative. Well, remember, the leading coefficient determines the right side of the graph. So the leading coefficient is not negative, it's positive. So the only one that's true is A. All right, and then it says, oh, we're supposed to use this graph 10 through 12. All right, so on which of the following intervals of x is g of x increasing? So that means when we read it left to right, where is it going up? So it's increasing from here to here and then from here to here. Remember, if it's increasing, never, never, never brackets. It's always going to be parentheses. Um, but let's just take a look. We know that it's not negative infinity to -4. We did not draw that. It looks like we're going from -4 to -1. From -1 to 2 is decreasing, so that's not right. And then from 2 to infinity is also increasing. So we're looking for 2 and 4. So that means we're looking at E. 12, which of the following statements are true about the graph of g of x? So the graph is decreasing on the entire interval from -1 to 2. So let's take a look. Where is it decreasing? From -1 to 2. That's not the only place, but it is going to be decreasing on this entire interval. It's not the only place, but it doesn't say that's the only place. It just says the graph is decreasing on this entire interval. That's true. The graph of g of x has 2 points of inflection. So now we need to go back over here and remember where the inflection points are. Inflection points are where there's a 0 with multiplicity of 3. So that's not the case. The inflection point is going to be between a max and min, the midpoint. So there's one inflection point. Here's another inflection point. And then the other inflection point is, well, that was one from the 0 to a max or a min. That's one statement. And then max and min. And so there's only 2 inflection points. So 2 points of inflection. So that is also true. The domain is all real numbers. Well, let's take a look. Is there a whole? Is there every x value that's represented? That's true. Polynomials are all real numbers. So we're looking at 12 as being E. Which of the following are solutions on the interval to this inequality below? All right, the nice thing about this, guys, is it's already factored for you. So now we just need to find out what our zeros are. All right, so our zeros are, we've got x is equal to 0, x is equal to -2 twice, x is equal to 3, and x is equal to 6. So let's draw our number line. We've got a 0 here, we've got a -2 over here, we've got a 3, and we've got a 6. So those are where we're drawing our number line here. All right. So let's see, we've got 1, 2, 3, 4, 5 factors. All right, so we've got, and don't forget about that negative right there. So we've got 1, 2, 3, 4, 5, and then a negative. Okay, we've got, I'm running out of room for here on this one. 1, 2, 3, 4, 5, and then a negative. 1, 2, 3, 4, 5, and then a negative, and then 1, 2, 3, 4, 5, and the negative. Now you could apply that to negative x, but I didn't do that. I just made the x value whatever we pick, and then we'll just count that negative. 1, 2, 3, 4, 5. All right, so let's go ahead and pick. Let me pick -3, a -1. Let's pick a +2. Let's pick a +4, and let's pick a +7. And so now I'm just going to go ahead. X is, and again, this is a -3. So x is -3. X plus 2, -3 plus 2 is going to be a negative twice because of that. X, -3 minus 3 is a negative, and then a -3 minus 6 is still going to be a negative. So I've got 1, 2, 3, 4, 5, 6. So this is going to be a positive right here on this interval. Now let's go -1. So I've got a negative here. -1 is going to be a positive twice, a negative here, and a negative here. So I've got 1, 2, 3, 4 negatives. All right, so let's take a look at 2. I've got a positive twice, a negative, and a negative. So that means I've got a positive. And then I've got, oh wait, I forgot about that other negative here. 1, 2, 3. So 1 2, 3. This one's a negative. That should be a negative. Forgot about that leading negative here. Let's do a 4. So this is a positive. This is a positive twice. 4 minus 3 is positive. 4 minus 6 is negative. So it looks like I have 2 negatives, which make it a positive. Let's take a look at 7. So I've got a positive here, positive twice, a positive, and a positive. Overall, that's going to give me a negative because of that leading guy. All right, so now that I've established that, let's take a look. Where is it greater than 0? In other words, where is it positive? So I am positive from negative infinity to here. Also from here to here. It doesn't say equal, so I can't include those. Each time I have to have an open circle. All right, so from negative infinity to negative 2. So that interval right here is not right because of the fact that it includes negative 2, and that's not okay. This interval from 3 to 6, notice that it's not brackets. So from 3 to 6 is positive, and then from 6 to infinity is not true. So we are looking at Roman numeral 2 only. So 13 is C. All right, last multiple choice. Which of the following statements is true about this? X minus 4, which tells us that x is equal to 4, is a factor twice. So x is equal to 4 is right here. It's not even a 0. So that's not true. Now, negative 4 is a factor twice, but that's not what the factor is. All right. X equals negative 4, which means the factor would be x plus 4. The equation of h of x has a negative leading coefficient. Remember, the negative leading coefficient tells me that I'm falling to the right, so that's true. And the graph has 3 points of inflection. So let's go ahead and count those. So at negative 4, that is not an inflection point. That is tangent to the x-axis. Inflection points are the midpoints between max and mins. So there's one right here. Here's another minimum and a maximum. So here is another inflection point. And then I do not also see where it changes concavity in terms of like that chill anywhere on the graph. So we've got 2 points of inflection. Let's see, and let's see, B, 2, and 3. So let's see if we can find another point of inflection. Oh, I missed that one right here. Look at that. A minimum and then a maximum. So this guy right here is going to be an inflection point. So inflection point right here, that makes the third one. So just really quickly, the definitions, I don't see a chill, but the definitions are going to be between max and mins. So here's a minimum and a maximum, and it's the halfway point. Here's a max and a min, and here's the halfway point. Here's a minimum and a maximum, and there's the halfway point. So there's 3 points of inflection. So that is also right. So 2 and 3. So 1 was not an option. And then B would be our final result for 14.